Thanks. My name is Karina Hoyer. I'm the Executive Director of Resources for Sustainable Communities. Woo! Thanks. And I am here to welcome you tonight to Imagine. Imagine energy independence by 2050. It's a pretty spectacular thought. It's great to have the lights on in the crowd, too. I recognize about half those faces out there. Tell you, talking in front of a crowd is a little nerve-wracking until I realize who's here. I feel like I'm at a party and all my favorite people are here. Woo! Okay, let's clap some more. Thanks. Well, we are so lucky to have Dr. Dan Kammen here tonight with us. But before I bring him up, I just want to thank some of the sponsors of tonight's event, people who made this event happen. Oops, I think I hit something. Can we ignore that for just a few minutes? Thanks, Matt. Yay, Matt! First of all, we got it. I'd like to thank Kulshan Cycles, a community partner and sponsor who has been supporting resources for years. I'd also like to thank Village Books. Village Books is also another local business that supports the community, gives back. And another big supporter of tonight's event is the Community Energy Challenge. And let me just take a minute to describe this program to you for those of you who don't know. This is a program that's really locally based, but kind of a national leader. The Community Energy Challenge is designed to provide homeowners and business owners with low-cost energy efficiency projects. So they will come into your home or business, they will assess your energy needs, they'll assess your energy use, and then they'll help you access funds to make those retrofits happen. So it's a great project. There is information out there if you'd like to sign up. Also, our other sponsors are represented out at the info fair, so please make sure to visit those booths. Finally, our sponsors were Azimuth Integral Homes, Ecotech Energy Systems, and Puget Sound Energy. So thanks to all of those businesses for helping us tonight. Now, I think I know the answer to this, but just out of curiosity, can I hear from the folks who do know of resources, if you know what we do and who we are? Yay! All right. Well, for the 4 people that didn't clap, I'll tell you. For 30 years, Resources has been working in this community towards sustainable solutions. We have a vision for Bauckman County. This event tonight is part of that. But our vision overall is that our waterways are swimmable, fishable, and drinkable. Yeah! Our climate is stable. Natural resources are used wisely and then reused, and coal is kept in the ground. We also envision that local communities can meet their needs for things like water, food, and energy. Like some of you know, Resources is willing to fight for these values, and we frequently ask you to join us, like in our fight against North America's largest coal port facility that's proposed at Cherry Point. No, we're not going to clap for that one. Right now, and I'm going to make this brief, right now you have the opportunity to voice your concerns through the public comment process. They are accepting public comments through the scoping period, and there will be hearings around the region to talk about the coal port, to express your concerns. They're called scoping hearings. The first one is going to be at Squalicum High on October 27th. Visit our Power Pass coal booth outside to get more information. But tonight is not about coal. It's about joining together to look into the future and define what we're fighting for. In the coming years, we're going to have some really big decisions to make as a community, decisions that will shape our future for years to come. So while you listen to Dr. Kammen tonight, I hope that you're inspired to imagine what a sustainable Bauckman County looks like. Think about, how will we get around? Where will our food come from? What will our neighborhoods look like? What will we do with our waste? How will we get our water? What will we do with our waterfront? With these questions in mind, we at Resources are trying to chart a course for the next 30 years. We're doing a visioning session with staff and board. And we're also asking you to participate by stopping by our Imagine booth. I saw many of you had already. Those blue sheets of paper that have the word Imagine on them, those are for you to express what you imagine a sustainable Whatcom County can look like. Post them on the board, get your picture taken with them. They're really gonna help inform us. We are a community group working for the community. We wanna hear what matters to you. And then we'll post your picture on Facebook and on our website, so it's kind of fun too. But with that, well actually, and the final thing is after Dr. Kammen's talk, we do have a couple of microphones up here. We'll open it up for a brief question and answer period. So as you're listening to him talk tonight, if something strikes you, you have a question, please feel free to ask that. We'll just ask you to line up here in the aisles and ask the questions. But with that, I'd like to introduce Dr. Dan Kammen. Honestly, I was trying to figure out what specifically I would say about him. I downloaded his resume, and it stalled my computer for like 4 minutes. It was so, right? He's shaking his head at me. It was huge. It's huge. I actually scanned his notable achievements, which are page 4 through 17. And they had words like global and world and energy czar and profound and amazing and spectacular. And I actually spent the afternoon with Dan, and I think that those were understatements. I'm really happy to host him tonight. He's the founder of the Renewable, I have to read this because this is tough. He's the founder of the Renewable and Appropriate Energy Laboratory. The acronym is REAL. Through his work with REAL, Dr. Kammen designs and implements renewable energy projects in communities around the globe. He is also a coordinating lead author for the Intergovernmental, which I always want to say intergalactic, but it's not, it's Intergovernmental Panel on Climate Change, which won the Nobel Peace Prize in 2007. And he was the inaugural Chief Technical Specialist for Renewable Energy and Energy Efficiency at the World Bank. That business card, by the way, was this big because that title is really long. Dr. Kammen has founded or is on the board of over 10 companies, has served both state and federal government in expert and advisory capacities. He's authored or co-authored 12 books, is a frequent contributor or commentator in international news media, has appeared on 60 Minutes, Nova, Frontline, and hosted a spectacular 6-part Discovery Channel series called Ecopolis. So with that, I ask you to join me in welcoming Dr. Dan Kammen to Bellingham.
Will
this one work for you?
No, I've got one. I'm all set. Karina, thank you so much for the introduction, and more importantly, thanks for having me here tonight. It's really exciting to be here for a bunch of reasons. Maybe the most direct is that you're here instead of watching baseball playoffs or other things. And events like this and communities getting together to talk through and debate and look at, examine the differences they have and the areas of commonality they have on a range of energy issues happens here, happens where I live in Berkeley and Oakland, California, but it's far too infrequent around the country. And as every politician in the room, and I guess those running for office, would you all please stand up? And I salute those running for office for a couple critical reasons. One is that it takes a lot of guts to do this. It's in many ways a thankless job, even though it sounds cool from the outside. And my community, scientists and researchers and authors on energy and environment and climate topics, haven't done anywhere near enough to provide elected officials, no matter what their political persuasion is, enough ammunition. And I'm going to talk about that as we go today. But if you think about it, one thing, and maybe the only thing, that politicians are uniformly really good at is getting elected, right? That's the job description. And if we want them to represent issues that are critical to us, we will bring them to the front. And this discussion tonight is really about that process. It's about no matter where you are on coal terminal or renewable energy or jobs or the quality of water for salmon, it's about making those issues front and center. And for way too long, those issues have been the second or third tier issue, not the lead issue. And so if we want this debate to be the debate about the world that we'll live in, and more importantly, our kids will live in, we'll have this much more commonly. And so gatherings like this on a Friday night, I can't be sort of more in awe of you all giving up your time to do this. And so I want to thank Resources for putting all the effort in behind this. But I really want to thank everybody here for being involved in the conversation, because that's the most critical part of the story. And as much as we care individually, we're not sending anywhere near a strong enough message that our elected officials from community to federal level put this in the center of their conversation. I don't mean a one-line throwaway line about are we going to eat Big Bird, or are we going to support a program that's funded some solar or wind companies, but I mean the ongoing dialogue. And so what I will use the time tonight to do is to really give my sort of opening comments on a much larger conversation. And we talk about energy independence, and we talk about it largely in political and ideological terms. But what I'll hope to do tonight is to unpack a little bit of the pieces that go on in that conversation. And if anything is useful, all the material that we put together in my laboratory is all available online. And I have learned the hard way that if you want the materials from the Renewable and Appropriate Energy Laboratory rail, don't just Google rail. Otherwise, you will get the railians who 5 years ago cloned a human in Florida. That's not my group. So if you put in Berkeley or my name or energy, you'll get to the rail laboratory where my students and visiting scholars and resident politicians spend a bunch of their time, including actual people like Jennifer Granholm, the ex-governor of Michigan. So all the materials I'll talk about tonight are available there. And I think the Cliff Notes version of my comments tonight are really that there's a couple easy steps. Now, I'm a physicist who thought he would be a physicist doing cosmology or particle physics, but couldn't resist all the exciting opportunities to take science around energy issues and get involved in a lot of real-world issues around the world. So what I'm going to try to spend the time, just about half, describing how at least our team thinks about many of the problems and what we often get asked to do by elected officials, and really describe a process that looks incredibly simple on paper. And that is, there's a stage in terms of examining and thinking about the options that are available and finding ways to be a part of the positive change, not just highlighting how bad climate change or how bad local air quality or river quality is, but really thinking broadly, as you're doing here, about energy options and about how important they are to everything else we do, and then finding ways to analyze these different issues. And that can mean community gatherings, engaging in people from Western Washington, University of Washington, our universities in California, using academic resources to do analysis that needs a mixture of local communities and national or international people, and then finding ways to implement. And I'll tell a bunch of stories that won't be just of local issues, but in almost every case, what got put together was a team of committed people, not always agreeing, but in finding ways to optimize and to find opportunities to build coalitions that brought energy solutions and to communicate those options to politicians. So I'll start off with a real simple point, and that is energy is remarkably central to our lives. And it comes up when there's a oil or gas or solar project that's on one's doorstep. But to recognize that energy is the largest industry on the planet in terms of movement of money and in terms of goods and services. This is the biggest part of our economy, and yet we're incredibly undertrained and experienced with how to make difference in this area. And so one of the things has already happened here. All of you are here tonight in thinking about how important this is to your economy. And if anything goes to elected officials, it's how much these energy issues matter. So first, I'll start off with a bit of a definition, because I'm an academic and have to sound somewhat nerdy in the process. And so I'll have no problem being nerdy. And the worry is that energy independence right now at the federal level really means not having to import energy from elsewhere around the world. That's unfortunately a version that's politically interesting right now, largely because natural gas prices are incredibly low, and I'll come back to that several times. But that's not really what energy independence should be about, in my view. Energy independence should be about having energy options today that improve the quality of life, not just of the rich, but of all of us. And many of our energy choices are biased far more towards making lives better for the already rich. But it also means making it so our energy choices leave us not just an okay world down the line, but a world that's actively better. And a lot of energy choices today are fool's gold. They're good in the short term, they look good in the very short term, but they don't do things good for us in the long term. So we need to find ways to make this kind of mushy term of sustainability one that's about jobs and quality of the environment and what world will my kids live in and their kids. And that's not an easy part of the process, because every politician in the room can tell you it is hard to look beyond the next election cycle. So there's an accountability that we all need to require of politicians. Frequently, the energy stories that we get told and we talk about relate to international problems due to oil. And so one of my colleagues said a bumper sticker that he woke up one night dreaming about was one that said, "What's our oil doing under their country?" And that's a really frightening story. And so starting the conversation, we should all know where our oil comes from. The United States has been in decline in oil production in the lower 48 states since the 70s, and even with the Alaska discussions, we are no longer on the producing edge. We're still a large producer, but as you dwindle in terms of your resources underground, a lot of bad things happen. When the OPEC oil crisis hit in the 1970s, our economy was held hostage because 6% of our supply was cut off. Not 90%, not 96, 6. That's the amount of oil we were getting from the Gulf at the time that we were embargoed, when inflation went through the roof and there were oil and gas lines. The little kids can't remember, but older people can remember how much it changed our existence. For a few years after that, we were an innovative energy leader. Even though he doesn't get a lot of credit for it today, President Carter passed a number of game-changing energy laws that led to many innovations, better solar panels, that we were producing but were now being outproduced by China, among others. We started an energy innovation, but we didn't follow through. So a bumper sticker that I did see was actually this. Notice that, of course, it's on a Prius, right? And so thinking about our energy independence in terms of where do we turn to get more of this stuff pumped out of the ground is really a bizarre version of the story. And unfortunately, not only the coal terminal issue here, but also where will we get more oil and gas from is all about this story. And there's a huge, compelling short-term part of the story. Don't discount how compelling those jobs or those dollars can be in the short term. But as I'll try to show you, we have story after story in our history that being more energy efficient and being more energy independent in the way that I'm talking about it, in terms of better lifestyles, really does change the equation. So I'm going to go back to World War II. There was a poster on the walls that said, "When you ride alone, you ride with Hitler." Car share today. This is 1942. And of course, a friend of mine who's in the media much more than I am, Bill Maher, stole it and updated it. But I don't begrudge it. In 2002, he said, "When you ride alone, you ride with bin Laden." And this is really about there's always going to be some producer looking for a way to make a fast buck off of fossil fuels. Now, I'm not saying that fossil fuels are bad for us. We built our economy. A huge number of jobs are related to it. So it's not an either-or world today. By 2050, it's going to have to be. And I'll come to the climate story as a little bit of that in a bit. But the economy that we need to build is robust, sustainable, and finds ways to ride out various shock waves. So when I look at the change in our economy, measured both in terms of economic shocks and measured in terms of global pollution, greenhouse gases, here's a graph that actually worries me. Now, I recognize it's a little bit on the nerdy side. Sorry, Karina. But if we look back to the 1960s, if we look at greenhouse gas emissions, the oil crisis in the 70s put a kink in our growth rate in emissions and our economy. The savings and loan crisis put a huge crimp in our economy, and we saw a depression that we can see in reduced amount of greenhouse gas emissions. The collapse of the former Soviet Union had a short-term decline in energy use because basically their economy shut down. The Asian financial crisis, all of these things put a kink in our emissions. One perspective of the world is that as we see more and more impacts of our fossil fuel economy, we'll find ways and innovate and find new clean energy options to build out solutions. But the most recent global financial crisis did something else. The decline in the economies in the US and in Europe did not result in one of these historic reduction in greenhouse gas emissions because we used less oil and coal and gas. What happened instead was that as our economies in the West did poorly, China in particular did remarkably well. And in fact, what happened is the Chinese economy grew dramatically. Much of the $6 or $7 trillion in the bank in China from manufacturing is not only on the backs of very inexpensive labor in China, but it's also on the backs of us buying products made with their cheap coal and their cheap labor. Now, this is also not a talk that's anti-China. In fact, while China is right now, unfortunately, the largest user of energy in the world and the largest polluter of greenhouse gases, China is also the country that's producing the most solar panels, the most batteries for electric vehicles, and the most wind turbines. And they weren't the leader in any of those 9 years ago. So that's an economy that is going, I would say, every direction at once. It's the biggest polluter, but it's also the biggest producer of a clean energy economy. Well, this is partially unfortunate because we, in the US in particular, were the innovator and the designer of many of those clean energy systems. But by not following through, we gave up the production side. So we did the hard work initially, but they're reaping a great deal of the benefits. So this is not an economic system that makes sense. If I think about the various threats to being sustainable, there's a whole range of them. We want to have a better quality of life, so we seem to want more goods. We want more cheap goods, so we import from China. In our current economy, that means we burn more fossil fuels, so we have more greenhouse gas emissions. The greenhouse gases lead to all kinds of negative climate effects, from river issues to agriculture to health. And we have reduced well-being as a result. And so if I think about that, there's a whole a number of places where you can break the chain. You can conserve. You can be more efficient. You can transition to cleaner sources of energy. You can use carbon capture if you believe it works, although I'm ambivalent about sucking down our emissions and putting them somewhere. There are people who think that we should geoengineer, put mirrors in space. I'm not a fan of that one either. We're going to have to adapt. The rivers aren't going to be the same. Agriculture won't be the same. My personal view, my personal hope is that by acting now and by doing more of these things, we can do less adaptation. But we're going to have to do some. So clean energy deployment and energy efficiency. We might want to do the interventions. I'm not a huge fan here. We're going to need to adapt. And I've left one bar out on this graph. We can simply have a reduced quality of life. That's called suffering. And unfortunately, most of the world history indicates that if we don't manage this process well, the poor will suffer the most and they'll suffer first, because the rich have ways to insulate themselves from a lot of this. So there's also an ethical component, and we keep talking ethics, but not doing something about it. Well, we know that a clean energy economy is a way to benefit the lives of the poor much more readily than just something for the rich. And so it's something to think about. Now, I've highlighted a range of the issues. I'm not going to try to teach a lecture on climate change in a few minutes, but in fact, part of the motivation for a clean energy system is green jobs, is not exporting just coal, but finding ways to export cleaner energy products. But if you look at the media barrage on climate change, even though that Nobel Prize that Karina mentioned that was given out to the roughly 2,000 of us who worked on these intergalactic reports on climate change, have worked pretty hard, and that's a global community. When you look on the media story, it's a huge barrage. And every time I go on to talk about the science of climate change, in almost every news media, they say, oh, well, even though all these climate scientists are in agreement, it has to be a so-called fair debate, so we have to bring online a skeptic. So you get this barrage part of the story. Most of the climate science stories you hear is something like this. Well, there's been a long history of the amount of greenhouse gas in the atmosphere. It's gone up and down over the last 500,000 years, and now we're shooting on up because that's what our models tell us. One of the areas where, in my opinion, the science community, as hard as they work, have failed public groups, nonprofit organizations, and politicians is finding ways to tell that story succinctly. Because you're not going to get a chance to do a 45-minute lecture all the time. In fact, the joke is that climate scientists and people getting Nobel Prizes for new innovations in science and technology, they're happy if they go on Science Friday with Ira Flatow for 5 minutes, whereas a climate denier can have a whole movie or a book of fiction and go on Oprah and all kinds of things. So we've got to find ways to rebalance the story. So I'm going to show you one example, and anyone who wants it can download this version from that website, that Rail site. And I use this one because it's incredibly short, and there's absolutely no modeling or no science in it. So I'm going to show you a very short video, and it's going to show the amount of sea ice over the North Pole. And it's a snapshot taken by NASA during the minimum, which happens in late August to September each year. So it's going to be a series of movies of the minimum, and then I'll just plot as a graph overlaying that movie the overall pattern. So what you're seeing here is a million square kilometers of sea ice during the summer minimum going back to 1980, and no surprise, climate records are noisy, which is part of the problem. They go up and down. I debated so-called Bjorn Lomborg at this period of time right here when there was a lot of sea ice. He told me, oh, there's no climate change. And I said, Bjorn, open your eyes and watch for more than a few years. This is the record when you go back from 1980 to today. Now, you'll notice there was a low year and a high year, just sort of counterbalancing that. When you look across this 30-year record, the amount of sea ice in the Arctic has dropped by a factor of 2 in 30 years. This means all kinds of things that we know what it means in terms of change of ocean chemistry. University of Washington was the hub for an incredibly important study that looked at this data and took some basic chemistry, and their conclusion is if you like tropical corals, if you like scuba diving or snorkeling, do it now. Because in 3 to 4 decades, there will be no more tropical corals. If you like doing Arctic diving, you're fine. But if you like warm weather diving and you like corals, do it now. And the problem is that we are using up our fossil fuels without finding alternatives. And part of that fossil fuel digging the bottom of the barrel is a story that many of you have heard of, the idea of peak oil. The idea that oil exploration rose, and in the 70s we peaked in our US production, but other countries have come online. And a geologist named M. King Hubbard studied this, and he found, no surprise, that many resources, they rise in production and then they fall. That story is called Peak Anything. It's called peak oil in this case. And when you look at the explorations for oil, the United States, Russia, Africa, Middle East, they rise up and they rise up, and they typically fall in a smooth curve, but you'll notice there's a bump on this curve. Hubbard was right overall, but as we get addicted to something, we find more and more ways to get unconventional versions, and I'll come back to those in a second. What's filling up this curve? Why isn't it kind of a perfect bell curve, a perfect Gaussian? We're finding ways to draw out the oil age. M. King Hubbard and all the world's geologists were right. We've used up about half of the world's oil. We're about in here, but we're finding ways to add on a series of other, even more polluting fuels, and I'll get back to that in a second. When we talk about this, we think of where is that oil coming from? Saudi Arabia is the current largest producer, and they are on the downward side of their production, but there are other producers coming in. And this has been talked about a great deal, and often, ironically, it gets talked about in the words of a resource curse, meaning the amount of democracy in Saudi Arabia is not ideal. The quality of life for many people is not ideal. And in fact, if we look at places that have transited through resource peaks, meaning they were huge hubs of fossil fuel extraction, such as West Virginia, massive coal-producing region. Well, in fact, if you look at West Virginia today, the peak areas of coal production are also the peak areas of unemployment, of ill health, and of out-migration. The legacy of extractive resources around the world is one of lower quality of life for the people who are involved in it. And the reason actually isn't that surprising. You don't need to do complicated demographics. Mining out resources, as I'm going to come back to with that oil curve, is one of digging harder and harder for the bottom of the barrel. When we got oil out of East Texas and of Pennsylvania, the first bunch of barrels are easy. But as you get more and more addicted, it's more costly in terms of health and energy and lives to dig out those last barrels. So we have, unfortunately, a nearby example of a place ramping up their production, extending the life of our fossil fuel dictated economy, and one version of that is Alberta. So Alberta and actually Venezuela are the home of what used to be called tar sands. My Canadian friends say, no, 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 we don't call it tar sands anymore. Now we call it oil sands, because oil sands sounds better. Well, it turns out that Alberta has more oil in this solid form than Saudi Arabia has of regular oil. If it takes 1 unit of energy to pull out of the ground and refine and ship to us 1 barrel of Saudi oil, it costs between 1.25 and 1.5 units of energy to extract the oil from this stuff. That just sort of makes sense, because this is a solid. The Saudi oil is a little bit more, more like a liquid. It's not as much of a liquid as you think, but it's more of a liquid than this. And if you go to, say, Fort McMurray in Alberta, anyone been to Fort McMurray in the room? You will see these. These are the piles of sulfur. This is the waste sulfur. You can see these from the space shuttle. These are the piles of waste sulfur from the process of refining out the sulfur impurities. Now, Alberta actually does a relatively good job of piling these up. The oil and tar fields in China are nowhere near this neatly organized. This is not Lake Athabasca. This is the settling pond of the waste water from doing this process. This is where that waste, that extra energy goes, and this is the kind of extraction process that you get when you're trying to extend that oil era. So while we say that we've used roughly half of the world's oil resources, the academic footnote is we've used roughly half of the world's conventional, easy-to-get resources. When we add these Canadian and Venezuelan tar sands and the rock, the shale in Utah, that we could also turn into oil, we haven't used up half of the world's oil. We've used up around 1/40th. But we've used up much more than half of the atmosphere. So we have an equation here which is not balancing. And that equation is, we might have thought that because we've used up a lot of the oil, we would start to push more aggressively towards alternatives. But what we're finding is, because this industry is so profitable, that we're finding ways to dig in and use more and more of this stuff. Now, I'll tell one more sort of unfortunate story about the Canadian tar sands process. Because ironically, how do they separate out the sulfur? This is not a story about Canadian problems. Many of the companies that are doing this are US companies and French companies. But to get the oil out of that bitumen, as it's called, this dirt material, they bubble natural gas through it so that the natural gas can kick out the carbon to the air and grab the sulfur. And they're doing it because natural gas is cheap and oil is expensive. So it's economically a good deal to use the gas to produce oil for us to buy. And the real irony is that the gas they vent to the atmosphere is actually largely hydrogen, which is, of the fossil fuels, the cleanest version. And I'm glossing over a lot of chemistry here in terms of that. Hydrogen is actually bonded to carbon. But basically, because of our appetite for oil, we have driven companies to scrape the bottom of the barrel, to really dig in for all these dirty resources. And we're finding lots of other ways to do it. This is basically a snapshot of the Deepwater Horizon disaster. When you look at new horizontal drilling techniques, the Deepwater Horizon wasn't some simple little oil well. The reason why it took so long to cap was that well was under a mile of water and then 1.5 miles of mud and rock. No surprise it was hard to plug that well. This is what a modern drilling ship looks like in terms of extracting these resources. And the problem is, the oil story is very similar to the coal story. When we look at the global curve for coal, it's got that same general shape as the curve for oil. And the estimate is we will be on the downside of that production curve for coal as soon as 2020. There's always a lot of uncertainty in the years. But what this is saying is that building, for example, a coal terminal, even if it produces a bunch of short-term jobs, is likely to put you on the dirty side of that equation long after we're past the peak, so that the people who are involved in that process, are on that dirtier and dirtier side of the equation. That is not a sustainable picture the way I've described it. So I feel like, in many ways, this cartoon kind of sums up my perspective. Even if the climate story isn't right, what if we find ways to generate more local jobs, to make the cities cleaner, to clean up air for our kids and actually lower the asthma rates, et cetera, and we do all that, oh, and climate change wasn't real, which the science says it is real. We've done all these things for no reason is sort of the debate that we're hearing internationally. Whereas we know that's not the case at all. The Sierra Club, actually funded by Republican Mayor Bloomberg, ran a wonderful series of ads, in my opinion, that highlighted that the biggest filters for much of the coal burned around the world were, in fact, the lungs of children who were living near those. Some of those children are here, but many of those are in China and elsewhere. So finding ways to bring these stories home is absolutely critical. But we can't only think about this in terms of what are our options to use less. We've got to find the other side of the story. And part of that is that our economic frame is in a very weird situation. So at one level, how do we think about the costs and the impacts of our choices? Now, I'm not saying that energy should be more expensive. What I'm saying is we've made fossil fuels too cheap. How do I mean that? Well, one way to think about it is that any one of us, if we go out and we work, we ride a bike, we work in the yard, whatever, for a day, we produce about 1 kilowatt-hour's worth of work. That's enough energy to keep 100-watt light bulb burning for 10 hours. Where I live, power is a little more expensive than it is here. It's about 11 cents for a kilowatt hour. that means that one day of your hard work, or my hard work, in fossil fuel energy terms is worth about 11 cents. That can't be right. That doesn't mean that our labor isn't worth much. What it means is that we have found ways to subsidize fossil fuels. So as much as we hear arguments that we shouldn't be subsidizing energy efficiency and renewable energy, we have to actually keep a little perspective. The global community, all the nations of the earth, subsidize fossil fuel production annually to the tune of between $400 and $600 billion in terms of credits and subsidies for more fossil fuel energy production. The total global subsidy for renewable energy and energy efficiency is about $30 billion. The total renewable energy industry worldwide is worth about $130 billion. And the total subsidy for fossil fuels is about $400 to $600 billion. So we're not even putting our basic subsidies in the right place. So I'm from a small town in upstate New York. And as part of the dialogue over this in the 1970s, the town I'm from, Ithaca, New York, founded something called Ithaca Hours. And Ithaca Hours are a local currency where the unit of currency is time. Because the time of a person who cleans houses or does carpentry or is a dentist or is a professor, it's still an hour of their time. We value these financially incredibly differently. But this was an effort on Ithaca's part to allow you to work and to trade those units. And in fact, you were able to pay not just at the farmer's market, but you're able to pay your mortgage and all kinds of things using these locally traded units. Now, this is in some sense an extreme, but it highlights that there are other ways to value our time that we don't always do. And of course, businesses generally don't value things if they don't measure it. So we need to send a clear message on this part of the story too. So in my closing part, I want to highlight a bunch of examples from around the world of communities that were engaged in discussions very much like what you're involved in and have come up with really interesting solutions. And they all relate back to that first slide, where the combination of having the dialogue and getting the analysis done and then debating out the options is really critical. So I'm going to start off with a very far-off location. And this is Sabah. This is the Malaysian province of Sabah, the northern part of Borneo. It used to be called the British North Borneo. The capital of Sabah is, the capital of the country of Malaysia is Kuala Lumpur. The capital of the region is Kota Kinabalu. And the worry that they had was that the government in Kuala Lumpur had said that because the quality of power is very poor over on the eastern coast, they would build a coal plant right here. They would buy that coal plant from China, and they would buy the coal from Indonesia, and they would send it up by barge, one barge a week, to land here in an area they'd also designated as the Coral Triangle, an area they were trying to promote for ecotourism. And they called me after they'd already signed the deal with China, and the national utility, which owns the local utility, had signed off on the deal. And my first reaction was, yeah, this looks great. I happen to love going to Borneo, but too little, too late. And they said, well, what can you do? So I had a bunch of meetings and discovered that there was a whole bunch of interesting aspects of the story. One is, and this is not an easy solution, this is also the largest refuge of orangutan on the planet. And actually, the very few remaining dwarf rhinos live right here as well. And they wanted to make this an ecotourism zone. And Indonesia had just signed a pledge that they would cut their deforestation rate, and Norway would give them $1 billion to do so. Now, their timber is worth much more than $1 billion, so they were taking a hit to do this. But we pointed out to the Indonesian government that exporting coal to Sabah while trying to get $1 billion from Norway to preserve your forest, that equation didn't really work. So Indonesia pulled back on their interest to sell coal. And we looked at the agricultural use of the land right here. Now, this is where the story gets complicated. Beautiful rainforests, but they're under threat because they're deforesting them to build palm oil plantations. Palm oil is a very profitable crop, but it comes at the expense of rainforest. When we looked at the energy options for Sabah, it was clear that by investing in energy efficiency and using waste from the palm plantations, they had more than enough energy. That's a weird balance, because what came out in the press is US professor says biomass can replace coal, and that's what I said. But what we did, what's buried in the article, was we got all of the palm producers to agree not to expand if they could sell their extra waste to make energy. And when I say extra waste, what they were doing it already was burning in open pits to get rid of it. So it made sense. But can I be sure that these palm oil producers aren't going to say, yeah, we took the deal now, and 10 years from now, we'll start doing more deforestation for palm oil? Because across Indonesia, sorry, I went the wrong way, because across this area here, palm oil plantations are expanding. So this is not a perfect one-time fits-all solution. But all of the current producers signed on, and the Norwegian government has held up their $1 billion until there's enough agreement of the producers here for those palm producers to engage in not only their current production, but to demonstrate that they're shifting to take part in this ecotourism industry. So it's not a perfect solution, but it highlights a process. And in fact, what happened was the Malaysian government then said, we reject and we tear up the deal to buy the coal plant, which they did. And at this point, they are investing in this mix of options. Now, I highlight this story partially because it seemed like it was dead and gone. They were going to build the coal plant, and they moved the other direction. And the fact that it's a faraway version shouldn't really get in the way of the conversation, because the next part of the story, sorry, I skipped one, is that there's a whole bunch of other benefits that we're seeing here, we see in California, Germany is making a big deal over, and that is the jobs benefit from investing in these different economies is dramatically different. My laboratory runs an online jobs calculator. It's, you can see it here, Rail, Berkeley, EDU, Green Jobs, where we assess by calling up companies, how many jobs are you generating? We call natural gas companies, we call waste energy companies, we call solar companies. And consistently, this is the average of those numbers, what we see is that an investment in a solar company or a biomass company produces significantly more jobs than a coal or a natural gas enterprise. Very much more for solar, somewhat more for biomass. But that if you think about it, the equation is even more dramatic than this. A number of politicians, a number of academics are involved in doing these calculations, and their numbers more or less agree. You get 3 to 5 times more jobs by investing in solar than you do in natural gas. You get 2 to 4 times more jobs by investing in wind. You get 1.5 to 3 times more by investing in biomass than in the fossil fuel options. And people argue about the numbers all the time. But if you think about it, in one case, in the extractive case, you are paying for coal or oil or natural gas. And no matter what the exact number of jobs are, if you're investing in solar or wind or fuel cells or ocean energy, all of that investment is going into people. You're educating people, you're founding new companies, you're investing in IP. And so no matter what the balance of the numbers are in terms of jobs per unit, you're investing in growing your economy. And given everything I've said about where we see the peak of conventional oil and that peak of coal, in the long term, this is a better equation. Now, that doesn't mean it's a better equation tomorrow morning. Right? The number of overnight jobs, if you build a huge industrial facility, can be higher. And so part of where our analysis is going, and the analysis of the German government and the Danish government and the government in Sabah I mentioned before, is that we see, if you look at this as one issue at a time, should we build this coal plant, or should we build this wind plant, or this solar plant, or this electric vehicle plant, you can make the arguments in this kind of the quantitative cost-benefit analysis. But the places that have really been able to do this transition have done the next step, and that's the hard part of the story. So I'll use the California experience to look at it, and no question, California has made a huge number of energy errors over its path. It is far from perfect. In fact, in 2000, 2001, some of you remember California had massive blackouts because we had an energy crisis that was basically a financial crisis that got played out in the energy sector. That story starts us in 2000, but what California enacted in 2006 was a climate law that did some kind of interesting things. So this was California's trajectory of greenhouse gas emissions going back to 1990, which is the international baseline year. The black is what we had done. The gray was the business as usual forecast. Governor Schwarzenegger in 2006 signed a law that said we have to get back to the 1990 baseline in the year 2020. The Europeans wanted us to go quicker. Others wanted us to go not at all. California is on pace to get back to that 1990 baseline in 2020. And it's not because of one piece of legislation. There's a whole bunch of pieces of legislation. But in the 2008 presidential campaign, California, as some of you may know, has a bizarre proposition process where any citizen, if they get enough votes, can put a proposition on the ballot. All kinds of good and bad things get on the ballot. A proposition got on the ballot to undo this proposition. This is called Assembly Bill 32. In 2008, Californians voted on Proposition 23 to undo 32. And it received a huge amount of financial support, and Californians voted on it at a time when the economy was doing terribly. And by a 60-40 margin, Californians voted to maintain this greenhouse gas law. That's something which I think actually took guts and really takes, puts things in perspective. Down economy, California had some of the highest numbers of foreclosures on homes in the country, and they still voted for this. The reason why that passed through was that California had done a couple things previously, of which Washington has also been a leader, so has New York State, Florida, Wisconsin, a number of states have been leaders. And again, I'll just put the California data up for comparison. This is electricity use per person in the country, overall in the country and in California. And what you see is they were both growing pretty steadily. Then the OPEC crisis hit in the 70s. The US rate slowed, but it still kept going. Through a whole series of rules around more efficient homes, better quality windows, better lighting products, electricity use per person, not overall because number of capitas has grown, but per capita has remained pretty constant. We're not even as good as they are in Denmark, but the leading states are 40% more energy efficient than the national average. What that means is that even though the electricity costs are higher in California than the national average, California has the third lowest utility bills per month. Because even though electricity is more expensive, we use less kilowatt hours. And a number of places have done this. Again, we're not even as good as Denmark. This is really an investment in efficiency first. And it's led to a whole bunch of innovations. So here's a picture of a convention center. This is in downtown San Francisco. And I was lucky enough to get in the day they were taking out these old incandescent lights, the day they were putting in the new T5 efficient lights. Not only do you see that the lighting quality is better, but actually, as Thomas Edison noted initially, 90% of the energy that goes out of a regular light bulb is heat, not light. A compact fluorescent or the LED lights that many of you have today give off most of their energy in the form of light. Well, when you light your building with old lights, you need bigger air conditioning units. You need bigger chillers. So this building, even with the cost to buy the new bulbs, saved $400,000 a year, even including the cost for the new infrastructure. So it turns out they didn't just pocket the money, which is what I would have done. They put the money into, at the time, it used to be the country's largest solar array. Now there's many, many that are hugely bigger. But when they did it, they put the money back into clean energy, and they invested in a number of companies like this solar thermal company in the desert in California. And the pride and joy of this company is that no part in this whole array is bigger than 1.5 meters. That's the size of one of these panels. Everything breaks down into these small units so they can sell these units around the world. So there are interesting innovations that can come out of this different perspective, this sort of cleaner energy economy. I recently got a chance to visit Vestas, the world's largest wind company. They install a windmill every 5 hours, and as the CEO joked to me, you know, our technology came out of the US National Renewable Energy Laboratory, but you guys decided not to commercialize it, so 4 Danish hardware and bicycle companies got together, founded this company, and we're now, we being this company Vestas, we are now having our lunch eaten by the Chinese that are outstripping the production using technology that started in the US, that got refined by some Danish national labs. And so by not investing in these cleaner economies, we're giving back and giving away a lot of these opportunities. One aspect of the story I want to use as I begin to close up is that as useful as academics are, and I think very useful, I better say that because that's my job, but in terms of doing the analysis and looking at the job issues and innovating in different technologies, there is historically there's no better route than getting on with the job. So these are the forecasts for the growth of the world's solar industry that were made by the European Solar Energy Commission in the 1990s. I was actually on this commission. We had 200 experts, and we did lots of meetings. We produced all kinds of how much solar is going to go into rural communities, how much is going to go into rooftops. You can see we use Excel a whole lot, and we did a lot of projections. Notice that all these curves are kind of the same. We scale things up and down. We thought we were being smart, but we were obviously very simplistic. We basically said, well, the solar industry is going to grow as fast as big companies install, but what happened instead was communities in Japan, in Germany, in the United States, found ways to pass laws to allow residences and homeowners to install solar. And instead of these curves, that's what happened globally. I stopped graphing when it went off the charts. Now, these 200 experts, myself included, they weren't just experts in solar. They were, they made their living in this field. They were solar experts who were really solar enthusiasts, and they were dead wrong. And they were proven dead wrong because of a very interesting feature. Everyone who was involved in this study saw the growth in the world solar industry as what's going to be the growth rate of this technology or that technology, and no one took into account the fact that if you get on with the job and allow local installers to put solar on and figure out what works and order from the companies to make better products, they will sort through the garbage really fast. And they will get to better cost-effective products. And that's what happened. The rates of learning in terms of better solar companies, better inverters to take the power out to make it into alternating current, better ways to mount it on your rooftop, all of those things happened remarkably fast. So when I told this story to Governor Schwarzenegger, he said, I can't even start the accent. He didn't say, "What are the jobs?" He said, "What can I do to push you?" And so I said, pass a law that's way ahead of what we're ready to do. He said, OK. And so the law he passed was, he said every new home built in California by 2020 has to be net zero energy. It's got to produce as much energy as it consumes. Now, that doesn't just mean solar on the roof. It can mean lots of efficiency and some solar. It can mean efficiency and your home is in a shady place, so you can't put solar on the roof. But the home has the right to buy a share of a wind farm. So this was not thought up by the academics. This was actually thought up by the city planners in the 4 cities in his kitchen cabinet, who said, let's push the folks. We now know how to do this. When this was first proposed, we weren't sure we could get it done. And then he got a little more excited, and he said, by 2030, all the office buildings have to be net zero energy. Now, unfortunately, we don't know how to do this yet. Right? So this is a problem. We do not know how to get this part done. But this is a really interesting conversation. We got involved in looking at the clean energy options, sort of told them this story. One of my students pointed out this is not so different than what happened in the Simpsons movie when I believe it was President Schwarzenegger said, "I choose option 3," or whatever it was. But we don't know how to do this yet. But researchers, not just in California, in Japan, in Germany, the University of Washington, are all applying for and getting state of California research contracts to find ways to make this happen. So we got a lot of catching up to do, but it's a long way from the story I described before with this kind of first generation of solar panels on the roof. So what I've tried to highlight, and I'm going to stop now because I've gone on, I know, too long, is I've tried to highlight not only are the problems we see largely because we're not tying together enough of the options, but we're also not engaged in enough of a conversation. Because as correct as we think we are on the climate science side, we're not communicating that story anywhere near clearly enough. And in terms of learning from the people who are actually pouring insulation and are installing technologies and are retrofitting buildings, we're not engaged anywhere near enough of a dialogue with the practical side. Now, that doesn't mean we don't critically need research. We don't have cheap enough solar panels. We don't have long-lasting enough fuel cells. We don't have safe ways to bury underground the carbon that we must emit, although I'm not real keen on that particular one, I have to admit. But we do not have that dialogue. And that dialogue starts with conversations like this, but it also starts with us demanding from people who are running for office that this is not the second or third tier issue or the one-liner in a presidential debate, but it's central to the story. Because all of these stories about sustainability are really about finding ways to make these technologies work not just for the rich, but for all of us. And that's not going to happen if the only technologies and policies are to make really expensive electric roadsters available for the super rich. It's got to be for housing developments. It's got to be about all of the benefits that come from reduced asthma, that come from the job issues. And that's one that neither the science, nor the politicians, nor the public are going to solve alone. It's going to take a much more public and central story about clean energy than we have already. So thank you so much for the time, and I'm delighted to talk further. It went a little long, sorry.
Yeah, no, that was really good.